Happy Friday-ish, right? At least for you guys. Okay, so I'm gonna keep the pace good here and fast because we got a quiz and we have topic questions. So you reviewed properties of inverses and applied them to trig functions. Okay, so the same thing holds true. X's and Y's are swapped. Inverses are reflection over the line Y equals X, which is why we have to start restricting the domain. So we talked about only using half the parabola yesterday, and today relative to trig functions, we know like sine and cosine, even tangent, all of them really are repetitive, right? The pattern repeats itself. So we take one pattern for a cosine that's 0 to 2 pi, and we take that pattern and it's 1 to 1. It's a situation where we have to make sure that when we rotate it, we don't get something not rotate it, reflect it over the axis, we don't get something that's not a function anymore. And that was kind of two of the problems. I can't remember what numbers they were, 1 and 6 maybe, had to do with that yesterday, right? That was why we were saying things like, we know the derivative of the inverse is negative, so we know it can't be positive, that sort of thing. Okay, and so hopefully inverses gives you a better idea of where that -1 comes from when we like solve for theta. Sine of theta equals a half. Then theta is the inverse sine of a half. It's literally swapping. If we said like y equals sine theta, it's literally swapping the y and the theta and having to solve to get that inverse. We know we need domain restrictions when we do this. That makes the function 1 to 1, and that allows us to narrow down the possibilities for the derivative of the inverse, because we know if it's negative, it's got to stay negative. It's positive, it's got to stay positive. We saw the patterns to the inverse trig functions are the key to remembering the derivatives. So, like I said, with the regular trig function, right, all the co-derivatives are negative. Same with the inverse trig functions. All the co-derivatives are and then we have to acknowledge that inverse is kind of out there stuff. Okay, so the College Board really emphasizes inverse sine and inverse tan. Okay. And the other ones are a really slim possibility of occurring. So if you're like, I can't take it, I can't remember 6 or even 3, to shoot for those 2. Okay, and you'll be fine, I bet, more than 90% of the time. And then that's number 6 is what we really are using the inverse trig functions for. It's the chain rule. That's really what we're using it for. We're going to be able to find the derivative of the inverse sine of 4x cubed. Okay, and so all that means is that everywhere I see a u in the pattern, I'm going to put 4x cubed. So it looks like I always do this. If that's the pattern, I put brackets squared, and then I go to put my 4x cubed there, and then differentiate to get the chain done. Okay. Multiple choice questions is where you see this. So you'll see this as 16x to the 6th in the answer options, but that's how that's working out. So any questions there? Okay. So oops. So you can write down the summary. You don't have to do it now. You can write it down when you have some more time in the class. But the idea is, how am I going to remember these? Prioritize, memorize inverse sine and inverse tan. Maybe inverse secant. That's a stretch. All right. So I'll leave that up. Maybe. And you can go ahead and open your quiz. Yeah, I'm gonna leave that up. And you've got some College Board after the quiz. And no notes to take. And one con. Okay, so I'm gonna back up and put that question back on the black